First of all, we can split the term triangle into two sub-classifications. Those are by sides, okay, by side lengths and by angles. By side lengths, we can split the triangle into three, and by using the angles, okay, by using the angles of a triangle, okay, interior angles of a triangle, we can split into three classification. By using side lengths, we can split this into three parts. First one, all sides are equal, okay, in a triangle if all sides are equal, that is called as equivalent triangle, okay, that is equivalent triangle. Then if only two sides of a triangle are equal, that is called as isosceles triangle, okay, isosceles triangle. And the third one, if all the sides, okay, when we consider about three sides in a triangle, all these three are different in lengths, all these three are different in lengths, we can name it as scalene triangle. Scalene, scalene triangle. These are things we can classify under the topic side lengths. Okay, first one is equivalent triangle. Next one is isosceles triangle. In isosceles triangle, only two sides. Okay, only two sides. When we consider about this side, this one should be equal with this one. We can use the similar hyphens to indicate these two sides are same. But in an equivalent triangle, all the sides are equal. We have to use three small hyphens to indicate all these three sides are equal. Okay, these are the classifications under this topic. When we consider about angles, we can split this into three portions. First one is acute triangle. Okay, in acute triangle, all the angles inside a triangle are less than 90 degrees. Okay, all the angles contained by the triangle are less than 90 degrees. Okay, we'll study them in detail. For your explanation only, I'm using this magnitude. Then next classification is right triangle. In right triangle, only one, okay, you will have the shape something like this, okay, shape something like this. Only one angle is equals to 90 degrees in right triangle. And the third classification is obtuse, okay, obtuse. In an obtuse triangle, okay, you can see a shape something like this, okay, one angle is greater than 90 degrees, okay. In acute triangle, all the angles are less than 90 degrees magnitude. In right angle, only one angle is equals to 90 degrees. In obtuse cases, all the angles are greater than 90 degrees. These are the major classifications of triangles. Okay. Then let's see all these six things in detail. Then the next thing what we have to do is area of a triangle. Okay, area of a triangle. For that, let's use three examples to find area of a triangle. Okay, when we use an acute triangle, okay, when we use an acute triangle to find the area, okay, this is the example for an acute triangle. Okay, in this acute triangle, we have to consider about the third participant, which is called as perpendicular height. Okay, perpendicular height. Okay, when we consider this side as our base of this triangle, okay, base of this triangle from its opposite vertex. Okay, this is our base of this triangle. From its opposite vertex, when we draw a perpendicular line, that is indicated as your perpendicular height. Okay, this length is indicated as your perpendicular height of this triangle. This is very important thing while we deal with triangles. Okay, perpendicular height. Okay, then to find the area of the triangle, we have to use the formula half into base into perpendicular height. Half multiplied with base multiplied with perpendicular height. That will give you the area of an acute triangle. Okay, area of an acute triangle. Let's do an example. Okay, for an example, I'll use this acute triangle and I'll indicate the perpendicular height. Okay, perpendicular height, which should be located inside the triangle. Okay, in acute cases, the perpendicular height should be located inside the triangle. When we deal with right angle triangles and obtuse triangles, in those cases, the perpendicular height might change in change due to the situation. Okay, according to change of the situation, the perpendicular height might change. Okay, now we are only focusing about acute triangle. In that, the perpendicular height should be located inside the triangle. We are indicate it as 6 centimeters, and the base, I'll give you the base as 21 centimeters. 21 centimeters. My question is to find the area of this acute triangle. For that, we have to use the formula half into base into perpendicular height. So half is the constant. So base for this triangle, this is our base. That is 21 centimeters. This one should be multiplied with the height. Height, perpendicular height, which is 6 centimeters. Then we can simplify these two. These 2 and 6 can be simplified. Let's see. In here, you have to multiply the numerators first. In numerators, 1 times 21 times 6. So that will give you 126 square centimeters. When you multiply the numerators, that will give you 126 square centimeters. This one should be divided by number 2. Okay, in denominator we have a 2. No? We multiply the numerators and this one should be divided by using number 2. Okay, number 2. When you divide, you will receive your answer as 63 square centimeters. 63 square centimeters. This is the area of this particular acute triangle. For the first one, half into the base is 26 meters into the perpendicular height is 11 meters. Okay, when you multiply 26 into 11, that will be 286. Okay, 26 into 11, that will be 286 square meters. Should be divided by number 2. That is 143 square meters. Okay, easy. Likewise for our next question also. But here you can see the orientation is little different. The base is given in slanted way, okay, in a slant, in a slope. But you have to conclude the things clearly. If we consider it as a base, the perpendicular height should be from its opposite vertex to the base. Okay, from its opposite vertex to the base. So this is our base in this case. So half into 19 into 4. So that will give you the answer as 38 square meters.